to Mr. Cheese YouTube channel.
Yes, busy way. But I just GCSE student. And guys, welcome to another episode of A2 Chemistry. And today we are doing Group 2 elements. So in this chapter, we're going to cover a few important elements, which is the thermal decomposition of Group 2 carbonate, Group 2 nitrate. Going down the group, remember thermal stability increases, and I'm going to tell you the reason why. At the same time, we're going to cover the solubility of Group 2 sulfate and also Group 2 hydroxide. Wow, don't know what's going on. Yeah, so Group 2 sulfate and Group 2 hydroxide, you guys need to know how to explain the solubility in terms of your lattice energy and your enthalpy change of hydration. Okay, so that will be all. And Group 2 is quite repetitive. Every single year also comes out as a 4 marks to 6 mark question. So this is quite easy to score. And please go through the video. Subscribe! Okay, let's go, kid. Okay, guys, right now let's look at thermal stability of Group 2 carbonates. Okay, guys, for Group 2 carbonates, right, let's say if you decompose a Group 2 carbonate, okay, so if you decompose it, right, so it forms a Group 2 oxide and also a carbon dioxide. Okay, so when you decompose a Group 2, you still have a bit of notes, right? Yeah, I have the notes. Don't worry, I have the notes. I will sign it over and you guys have to do it as a self-revision kind of thing. Alright guys, right now let's look at CaCO3 turn into CaO and CO2. So guys, you see, right, as you go down the group, a higher temperature is required for it to decompose. Okay, so a higher temperature is required, right, for the Group 2 carbonate to decompose. So guys, I want you guys to draw it out as you go down. Okay, so my Group 2 thermal stability increases here. Please write it down. Thermal stability increases. So it gets more and more stable, right? Okay. Alright guys, next. Question. I have a question. What is polarizing ability? Okay, I will talk about your polarizing ability later on, yeah. Okay, hey, wait. Have you done polarizing ability? Oh, you guys done it in chapter 19 already in school. So guys, what is polarizing ability? So we call polarizing ability, right, as the ability to polarize, okay, or to distort the anion electrons cloud. Alright, that's it. Alright guys, please write it down. Alright guys, next. Okay, you see, right, guys, the carbonate ion, right? Okay, so if you look at if you compare magnesium versus barium, so we have Mg2 plus, right? And we have Ba2 plus, correct? So as you can see, right, your Ba2 plus is a very big ionic radius, right? It's having the biggest ionic radius, right? Am I right? So when you have a big ionic radius, it means that what happened to the polarizing ability? You have a very weak polarizing ability, am I right? Okay, so when you have this weak polarizing ability, what happens to the anion? So the anion now is less polarized, remember? So anion is less polarized, which means it's more thermally stable. Understand? So which is why barium carbonate decomposes at its highest temperature. Reason, barium 2 plus is having the biggest ionic radius. Okay, so with polarizing ability, and ion is less polarized, and which make it more thermally stable. Okay, guys, please write it down, yeah. Alright guys, I can say that, right, the smaller, the carbonate ion has a small ionic radius, a smaller radius, hence it can be easily polarized. So guys, the conclusion is the smaller the cation ion, what happened? Okay, if you have a very small cation ion, right, you have a very strong, the stronger the polarizing ability, right? Okay, so highlight this part. The smaller the cation ion, the stronger the polarizing power. Understand? So guys, let's look at Mg2 plus. If you look at Mg2 plus, right, you see that it's a very small ion, which means you have high charge density, right? Okay, which means it has a very strong polarizing ability. Okay, what is electrons cloud? Electrons cloud is basically the shell. Understand? All these are electrons cloud. Okay, so guys, you see, right? Let's say this is a 2 plus. This is highly charged, So let's say if you place an N ion to the side, right? Okay, so this N ion will sort of get pulled towards your magnesium 2 plus. Okay, so right now, do you see that your N ion is more distorted now? All right. Correct. So when it's distorted, right, the bond in your CO3 2 minus, right, is weakened now, which means that it get decomposed easily. Understand? Because you look at your CO3, the CO3 2 minus, right, is distorted. The electrons cloud is being disrupted, which means the bond in your CO3 2 minus is weaker now. I understand. Okay, so which means it will decompose at a lower temperature. Done. Okay, and guys, let's look at your cation ion for Ca2 plus. Do you see that your cation ion for Ca2 plus is slightly bigger? So for this part, okay, your CO3 2 minus, right, is less polarized. Am I right? So when it's less polarized, your bond in your CO3 2 minus is weakened less. Am I right? Done. Okay, clear? Please write it down. All right, guys, now I can say that, right? The lesser the polarization, what happened? So the lesser the polarization, right, the harder it is, okay, to weaken the carbon-oxygen bond. Alright guys, the group 2 metal nitrate follow a similar pattern. So guys, for group 2 nitrate, right, when it decomposes, okay, so for group 2 nitrate, it's always 224, right? You should remember your 224 equation. So guys, if I have a group 2, example, magnesium nitrate, when it decomposes, it forms magnesium oxide, nitrogen dioxide, states in blue, oxygen gas, correct? So balance the equation, 2, 2, 4. Done. Okay, please write it down. Alright guys, now therefore thermal stability of carbonates and nitrates as you go down, right, increases here. Please highlight this part. Thermal stability of nitrates and carbonates increases down the group. Okay, what is the reasoning? Because your ionic radius increases down the group, right? So when your ionic radius is bigger, the charge density it's lower, right? Charge density decreases. Then the polarization of your carbonates electrons cloud or your anion electrons cloud is lesser, right? It's less distorted now. Okay, hence your thermal stability increases down the group. Let me highlight the keyword for you. Ionic radius increases down the group. Charge density decreases down the group. Polarizing of your anion is less. Okay, thermal stability increases down the group. Guys, this entire explanation can be 3 marks in exam. Okay, please write it down. This is a 3 marks answer in exam. It's always the same standardized answer. Please write it down. Yeah. Done. Great. Easy, boy. Good. Can I move on? Alright, guys, page 2 now. Okay, this part, right? You just do it as homework. I'm not gonna do it. I want you guys to look at solubility of group 2 sulfate. Alright, guys, let's look at group 2 sulfate. So before we do a group 2 sulfate, right, we have to recall one equation for your enthalpy and entropy, which is delta H solution. Guys, remember this formula? Delta H solution equals to delta H hydration. Then what happened? Minus something. Can anyone tell me? Minus what? What is delta H solution again? Now you need to know this equation. This equation is very important. Yeah. Delta H hydration minus something. What is the something? GG. Moment of silence. Minus delta H lattice. Done. Alright, so guys, highlight this entire equation. Delta H hydration equals to delta H. Okay, delta H solution equals to hydration minus of lattice. Okay, this equation, right, I haven't done it with you guys, but I believe your lecturer in some way, MCKL in Taylor's already done it. Okay, so please write it down. Alright, guys, from this delta H solution, right, delta H solution gives you two implications. So the implication is, right, let's say your delta H solution, okay, is positive, and your delta H solution, right, it's negative, what it tells you. So guys, for delta H solution, let's say your solution is negative or positive, what it tells you. Please tell me. Anyone? Anybody? No? None? Okay, so guys, when your delta H solution is positive, it tells you that this compound is insoluble. If it's negative, it's soluble. Alright, guys, please write it down. Okay, guys, right now, okay, let's look at the bottom part first. Okay, I don't want you guys to look at 0.2345. I'll explain based on the bottom part. So, guys, okay, you know that, right? As you go down from magnesium sulfate, MgSO4, as you go down to BaSO4, what will happen to the solubility? So the solubility decreases, right? In which this is soluble and barium is insoluble now, right? Correct. It's a white PPT, right? Now you have to explain this, right, based on your delta H solution. Okay, so guys, this is the knowledge. So group 2 sulfate goes down, it turns insoluble. Okay, now let's look at the, okay, I just want you guys to look at the bottom part first because I'm gonna draw something for you. All right, guys, if you look at Mg2 plus, right, you know that Mg2 plus is pretty small ion. Mg2 plus, right, is very small. Okay, then, if you look at a sulfate, guys, oh my god, sulfate on the other hand, this sulfate is pretty fat, because S, right, linked with 4 oxygen. So SO4 is pretty huge, guys. Okay, so this is a sulfate, just imagine it. Ding, SO4 2 minus. Ding. Okay. Okay, guys, let's say if you draw a BA is just slightly bigger than your, okay, it's just slightly bigger than your Mg. So if just slightly bigger than your Mg, it's bigger than the Mg. Okay, and guys, okay, so put together with a sulfate. I saw that. So guys, this magnesium sulfate, right, and magnesium sulfate and barium sulfate. Okay, so you can draw this out. Alright, guys, now, okay, let's put in their length, right? Just imagine I'm going to put in their length. Okay, and my length is just a hypothetical value. I just assume, okay, a value for them. Okay, so it's not true in actual. So, guys, just imagine, right, my magnesium is 0.1 nanometer. Okay, and for sulfate, right, you see your sulfate is so huge, it can be a 10 nanometer. Okay, so the same thing here. However, you see, right, as you go down, your barium, right, it's about 0.3 nanometer. It's around that. But your sulfate, right, is still standing at 10 nanometer. It's still very huge. Okay. Alright, guys, let's say if you were to compare, right, you see, right, what is the overall size? The overall size, right, maybe for magnesium is just 10.1 nanometer. Okay, then for barium, right, if you compare, Barium is just 10.3 nanometer, am I right? Understand the drawing? 10. So we have to explain based on the size itself. Okay, so guys, draw this out first. Then I'll show you how to arrive at your answer later. After this, what chapter should I do next? I think after this chapter, I should do transition matter with you guys. On Wednesday, I'm gonna do transition matter. Then on Friday, I'm gonna move on to Born-Haber diagram. This Friday, we're gonna do Born-Haber. Alright, guys, now let's go. Okay, kid, let's say right, if you want to compare my delta H hydration. So guys, I'm not so sure you know what is your teacher teaching transition method next week. Okay, good. Alright, guys, I'm not so sure. Do you know what a delta H hydration is? You see, right? So for delta H hydration, what we are comparing, right? So we compare the size of anion and cation separately. Remember, yeah? For hydration, right, we always compare the anion and cation separately. Understand? Okay, so remember, we compare it separately. Okay, so guys, you see, right? The bigger the size, okay, the less exothermic it is. Okay, so the bigger the size of the ion, the less exothermic it is. Hasan. Alright, guys, now let's look at delta H hydration of BaSO4. Okay, I can put BaMgSO4 and BaSO4. Alright, so guys, for delta H hydration of magnesium sulfate, okay, so let me search up the value. Okay, I'm going to put a real value here. Delta H hydration, LP change of hydration of MgSO4. What's the value? Okay, why is it less exothermic? Because when it's bigger, right? Okay, the charge is lesser. Okay, when it's bigger, the charge is lesser. The charge density is lower, understand? Okay, guys, I'm just gonna put any, because I'm looking at it, I can't really find it because what happened is that, do I have MgSO4? MgSO4, GSO4, MgSO4, ESO4, hydration energy, MgSO4. Okay, guys, now, okay, so I will just put any random number, okay? So to conclude, right, guys, you see, my MgSO4, right? Okay, so what happened is that, right, if you were to compare your hydration of magnesium sulfate and barium sulfate, right, you see, okay, what happened is that, right, your anion, right, and cation, we have to compare it separately. Understand? So we have to compare it separately. So if you look at sulfate, right, sulfate never changed, correct? Sulfate is the same. Okay, so what changes is just magnesium to barium, am I right? Because this part not changing, am I right? This part is not changing. Understand? So what happened is that, right, do you see that the magnesium to barium, right, the size is almost 3 times, correct? So just imagine, let's say this is 1200, right? My barium is going to be negative 400. So the energy, right, it's about 3 times lesser. This is just one example. Okay, yes, correct, because the size of anion is constant in this example. Am I right? So your hydration, right, is not being affected because hydration, we always compare cation and anion separately. Understand? Since these two stays the same, what we are comparing? We are comparing barium. Understand? Clear? Okay, so guys, since this there is a big drop, right? You have to explain based on the big drop. Why there's a big drop, right? This big drop, okay, I can say that this big drop of delta H hydration, right, is due to Okay, the ionic radius of cation increases. Understand? So ionic radius increases in size. But what happened to your sulfate? The sulfate is a constant, right? Am I right? So you see, right, my SO4 2 minus is constant. Am I right? It's not affecting any of the value. Okay, so I can say that, right? My SO4 2 minus is a constant. It's not changing. Hence, the increase in size of cation, right, is very significant. Understand? So I can say that, right, the increase is very significant. Like, just imagine, right, at first you build it as 50% and 50%, right? Right. So you see, 50% is not changing. Another 50%, three times the size. So the change is very significant. So which is why you get a big drop here. Understand? Okay, guys, please write it down. You have to understand the theory behind it. Actually, no need to understand also, it's fine. Because later I'm going to give you a way to memorize the answer. You just keep on repeating the writing technique, then it's okay. You don't even need to know the reason why. But I will show you the reason why first, okay? So later I'll give you the writing technique. Please write it down, guys. 1 more minute. So can say that the size change of is proportional to the size change of ion. Correct, you are right. Ion, individual ion. Okay, so Ivana, individual ion is inversely proportional. You are right. You are right. Correct already. Yes, it's inversely proportional. You are right. All right, guys. Now let's continue. Yeah. Okay, we are done with our delta H hydration. Now let's continue with delta H lattice. All right, guys. You see, right? How do you compare my delta H lattice? So guys, remember whenever you are comparing your delta H lattice, right? Lattice, we are looking at the overall. Remember, lattice, how we compare, right? We always look at its overall. Understand? So we compare the overall size of your combined cation and anion. Understand? So guys, again, for lattice energy is always overall. Okay, so let's say if you want to use the inversely proportional, right? It's inversely proportional to 1 over, it is inversely proportional to overall size of the compound. Understand? So that is delta H lattice. Okay, the similar things apply if you have a bigger size. Okay, then you have less exothermic. Okay, so if you have bigger size, it will be less exothermic. Okay, so guys, let's say if you compare it, my delta H lattice of MgSO4, just imagine I give you a value is negative 900. Guys, can anyone tell me, right, what happened to delta H lattice of BaSO4? Can anyone give me any value? Okay, guys, you have to tell me, would it be a big drop or a small drop? So the first question that I'll be asking, right, is it a big drop or is it a small drop first? Please tell me. Yes, it's a small drop. All right, so guys, what happened is that, right, for this part, it's a small drop. Reason you see, right, we are comparing the overall. You see, right, the overall is the changes, right, is just plus 0.2 over 10 point something. The overall changes is like less than 10%. So it's pretty small. Understand? For example, right, your hydration here, because we are comparing individual, right, this is 300% changes. Am I right? But this one, is 0.2 over 10.1 multiplied by 100%. The changes is pretty small. As I said, the changes is about less than 10%. So, which is why, right, the value drop is very, very small. Okay, the drop in value is very small. Okay, guys, why is it so? Because, right, I can say that the overall size, okay, doesn't really change, right? Am I right? Doesn't really change much. Why? Because my cation, right, is too small. Understand? Your cation is too small compared to SO4 2 minus. Understand? Guys, just imagine, right, you have two Titan. I'm not so sure you guys watch Attack of Titan. Yeah, you have two Titan, 2 meter high. Wee. Two Titan. Wee. 2 meter height. Just imagine this fella is 2 meter height. I put Jordan here, which is like 180 cm, and I put another fella which is like 3 times Jordan height, 540 cm, next to a Titan. You see, right? The changes is very insignificant. Am I right? Because this fella is way too big. So even though the size changes, but next to a Titan, right? Okay, it doesn't really make a difference. Okay, so which is why the overall drop is very small. Understand? Right, guys, please write it down. Okay, to conclude, right, guys, let's say if we were to calculate, you see, if we were to calculate my delta H solution of MgSO4, I know it's hydration minus lattice, right? Negative 1200 minus negative 900. I get negative 300 still, which make it soluble. Am I right? Okay, guys, always remember your hydration and lattice is always exothermic. It will never be an endothermic. It's always exo. It will never be endo. Never be endo. Okay, because it's energy release, not energy required. Okay, guys, next, my delta H solution of BaSO4. Guys, if you look at the value, right, it's going to be negative 400 minus 800, right? So this time is 400 now, which make it insoluble. See it? Yes, guys, remember hydration and lattice. Lattice energy and hydration is always exothermic. It will never be endothermic. Okay, so I thought you guys already done it in school. Your your hydration and lattice. Smacker, you were the first lesson your Sunday lecturer already done it with you guys, right? Is it? She taught it while in the ES, so early. Alright, guys, write it down. Didn't listen. It's okay. I will repeat again. I'll repeat again. Don't worry. Done? Okay, guys, done. Alright, now let's continue. Okay, let's look at your hydration. So, guys, okay, always remember, right? In sulfate, right, my hydration decreases more. I want you guys to put it here. Hydration decreases more. Okay, why? Guys, why hydration decreases more? Because we, again, right, I already showed it in the diagram below. Reason we are comparing individual size. Okay, so guys, highlight smaller ion have a more exothermic or more negative delta H hydration. Remember, yeah. Highlight this part. Hydration becomes less exothermic down the group. And highlight this part. The decrease is very significant. Put 2 stars here, guys. Okay. Alright, guys, next, let's look at delta H lattice. So, guys, the delta H lattice, right, the same thing. Okay, smaller ionic radius, right, will always have a more exothermic. Okay, will always have a more exothermic high delta H lattice. Okay, so guys, I know that, right? My delta H lattice, as it goes down, it turns into less exothermic down the group. Am I right? So delta H lattice decreases, or less exothermic going down the group. Don't use the word decreases, guys. I want you guys to either use more negative, less negative, more exothermic, less exothermic, things like that. Okay, so because decreases, right, it's very debatable. Like from negative 800 to negative 400, is decrease or increase? Like you can mention it's decreases because the value decreases, but in mathematics, it's increases. Okay, so it's not right. Try not to use decreases and increases. It's very debatable. Okay, so guys, however, the decrease in your delta H, right, the drop in your delta H, right, is very less. Okay, it's relatively less. Okay, highlight this part. Decrease in lattice is relatively lesser because, again, why? When we look at lattice, we are always comparing the entire ion, the entire compound, not individual. It's the entire compound. Okay, so that's it. Okay, guys, now this is the example of writing technique. Okay, let's say if you don't understand the entire concept here, right, it's fine. You can just memorize because trust me, it will always come out in exam. Okay, solubility of group 2 sulfate. First. Okay, so guys, I can say that, right? My hydration and lattice both decreases, or both becomes less exothermic going down. Am I right? Or less negative going down. That is the first point. You score 1 mark here. You have to tell me both becomes less negative. Okay. However, second part, change in hydration, it's more significant than lattice. Second mark. Okay, so that is your second mark. So guys, recall the formula. If you sub it in, my delta H solution, it's more positive going down. Okay, highlight this part. Delta H solution is more positive going down the group. Third mark. Okay, hence solubility of sulfate decreases down the group. Done. Clear. Up a bit, can. Alright, guys, please highlight this entire thing. I'll move on to delta H hydration. Yeah. I see a monster. Done. Guys, can I move on to next part? Can I? I can. All right, let's go. All right, guys, now I want you guys to look at the last part. We have solubility of group 2 hydroxide. Guys, this is the last part already. Group 2 is pretty short. Okay, so for group 2, right, we just have 3 pages of notes, and that's it, done. Okay, so guys, right now let's look at the first one. Okay, so guys, for group 2 hydroxide, right? Okay, so guys, right now, let's look at my example. You see, right, kid? Okay, so I don't want you guys to look at the point first. I just want you guys to look at how it changes first. You see, right, for group 2 hydroxide, okay, hydroxide is pretty small, yeah? Because hydroxide, right, O and H only. Understand? You see, this is SO4, sulfur is period 3. And this period 2 times 4. So it's a pretty big compound. But hydroxide, right, it's OH, period 2 and period 1. It's the smallest. So if you were to draw your hydroxide, right? Okay, hydroxide on the other hand, it's pretty small, like a tiny little one. Okay, so guys, that's your hydroxide. Okay, you see you have a cute little hydroxide here. Whee! Okay, then guys, this is magnesium hydroxide MgHOH2, right? Alright guys, what about barium hydroxide? You see for barium hydroxide, again, the hydroxide is not changing, but barium is bigger now, right? Understand? Alright guys, right now, let me put in the hypothetical value for you. Okay, so guys, maybe one hydroxide itself, right, is 0.1 nanometer, okay? This is 0.1 nanometer. Ta-dum, ta-dum. And this entire thing, maybe I just put it as 1 nanometer. This is 0.1, 0.1. And this, again, I put it as 1 nano. Hey, this is bigger, right? 3 nanometer, okay? Can I? Alright, guys. Right now, if you were to compare, right, the overall, it's 1.2. Am I right? The overall is 3.2. Can? Alright, guys, you can draw this out first. Yeah, I will explain the reasoning in 1 minute. Alright, guys, now, okay, let's go. Okay, guys, right now, right, if I were to ask you to compare delta H hydration. Alright, guys, you see, right, for delta H hydration, again, yeah, what did I mention about hydration? We are always comparing it individually, right? Am I right? It's always individually, remember? Okay, so you compare anion and cation individually. As I said, we are comparing it individually. Okay, guys, now, you see, I have delta H hydration of MgOH2. Let's say, right, I put it as 1000 here. Can anyone tell me what happened to hydration of BaOH2? Yes, guys, how? Can change this color? Can. Alright, so guys, the value, right? Okay, I can put it as negative. Okay, so I put it as 800. Okay, so guys, now let me ask you a question. You see, guys, why the change here is not very significant? Okay, so the reason being, right? Okay, so I just want you guys to put it here, the change is less significant. Can anyone tell me why? Alright, guys, why the change is not significant? You see, just now, we are talking about 50%, 50%. 50% constant, am I right? 50% changes. So which is why the change is very significant. Now, guys, if you were to separate individually, 33%, 33%, 33%. So guys, you see that 66% not changing. Correct. 33%, changes. Am I right? So out of this entire compound, right, it's just 33% changes. So which is why, right, it's less significant. Am I right? Okay, so because you have two anion, never change, right? So which makes about 67% unchanged. So if you were to split it, right, understand? Which means, okay, just the cation, okay, changes in size, right? About 33% changes size. Understand? Because if you look at it as 100%, this 33, 33, 33, right? Understand? So no change, no change, only 33% changes. So which is why the change is less significant. Understand, guys? Clear. Can. Alright, guys, please write it down. I'm moving on. Yeah. Alright, guys, now let's compare my delta H lattice. Alright, guys, to compare our delta H lattice, right? Again, for delta H lattice, we always look at overall size, right? Okay, so remember, guys, delta H lattice is always your overall size. Okay, so guys, let's look at your delta H lattice of MgOH2. So let's say, right, this is 1200. What about delta H lat of BaOH2? Okay, so guys, you see, right, the overall size, okay, the change is pretty significant, It's 2 over 1.2. Am I right? Multiplied by 100%, it's about 200% changes, if you can see. Okay, so I can say that the overall size change is about, okay, it's very significant. Okay, so guys, which means the decrease is very significant. Am I right? Okay, so the decrease is very significant this time. Okay, guys, why? Why the decrease is very significant? What's the reasoning? So because, right, in magnesium hydroxide and barium hydroxide, your cation is way larger than anion. Am I right? Your cation is way bigger than your anion, correct? Okay, so your cation is way bigger compared to your anion. Understand? So I know that the increase, oh my god. Okay, so this increase in size of cation, okay, contributes a lot to the overall size, right? Understand? Okay, so this change in your cation contributes a lot to your overall size. That's it. Okay, guys, please write it down. Done, yeah? So guys, to conclude, what I can say, can I calculate my delta H of magnesium, delta H solution of MgOH2? It's going to be negative 1,000 minus negative 1,200. It's positive 200 GG insoluble, all right? But guys, what about your solution of BaSO4? Not BaSO4, BaOH2. Negative 800 minus negative 400. It's 400 negative, right? Soluble. Okay, that is the reasoning. So guys, in your ES, right, you done your solubility, but you never know the explanation. Now in A2, you are doing the explanation now. Okay, so please write it down, kids. Guys, I'm sending chapter 25 over here, which is your transition element. I'm sending it over now. I think I can use it now. Can I? Let me see. Is this the latest version? Later, Ivana scold me again. Very scam. Ivana always scold me. GG. Hey guys, please write it down first, yeah? I'm sending chapter 25 over, which is your transition element. Alright guys, now let's look at the explanation, yeah? Alright guys, to explain this entire group 2 hydroxide, right? Very simple, yeah? So I know that, right, as the ionic radius increases down the group, the solubility of your hydroxide increases this time. Okay, highlight this part, increases. Okay, so guys, this is your 4 marks question, yeah? Okay, so this entire part can be a 3 marks question, okay, in exam. Okay, now, again, to explain the solubility of group 2 hydroxide. So first, I know that, right, my lattice and hydration becomes less exothermic going down, right, or less negative going down. Right? So guys, writing this always score you 1 mark. Okay, so writing this will always score you 1 mark in exam. Okay. Alright, guys, after that, okay, what I can continue. Okay, however, guys, which one is more significant this time? Okay, this time your lattice is more significant, right? Okay, so however, the change in hydration is less significant than lattice, or lattice is more significant now. Point 2. Okay. Alright, guys, next. Hence, delta H solution is more negative. Is this chapter very popular? Hey, guys, let me tell you, this chapter is very popular. This chapter, right, always come out in exam. Let me tell you, every single year, always come out in exam. It's always there, guys. It's always there. Always come out in exam. I'm not kidding. Like, always come out in exam, guys. Okay, so you guys better go and revise this chapter. Okay, it's pretty easy and pretty free marks for you guys. And it's always out in exam. Trust me, I see this question a lot. Alright, guys, please write it down. F1 blank. Okay, hence increases down the group. Done. Okay, guys, please write it down here. Sorry, I'm adding more homework for you guys on transition method because you guys gonna get 150 pages of note. This chapter, transition method, it's basically the most important part in your inorganic chem here. So which is why I'm adding a lot of questions for you guys to do. Hey guys, can you give me about 5 minutes? Yeah. Okay, can you give me about 5 minutes because I'm adding 2023 questions. I forgot to add some. I just realized. Just give me about 5 minutes. Okay, then I'll move on. Alright, guys, meanwhile, right, perhaps you can try this question out. Like, guys, try this question out. I'll give you one answer. Please go, go, go. Organic synthesis. Will you teach? Yes, I will teach organic synthesis. I will teach organic synthesis. I will. Organic synthesis is, yeah. Guys, try this question. I'll give you answer in one. Go, 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 go. Now, now, now. Yeah, I will finish nitrogen compound first. Can you chill? We'll finish the nitrogen compound first before we move on to the next. We have to finish the nitrogen first, my dear. Alright, guys, don't be surprised. I'm sending a 150 pages of notes over here. 150, yeah. Because for transition element, right? Trust me, this chapter, right, for transition element is one of the most important chapter in your A2, yeah. It's not one of the most important. It's actually the most important chapter in your A2. So you get a very lengthy notes from me. Just give me a minute. I'm just finalizing it. 150 pages. Good luck printing it. How, Ivana? Are you gonna print out 150 pages? I'm not kidding, it's really 150 pages, guys. Okay, yes, I'm done. I'm sending to the group now. God bless you guys for 150 pages. Okay, it's converting now. And guys, just give me 1 minute. Okay. File too big, takes so long to send. Yeah. Sorry, guys. This file is really, really huge. Because I thought it would take me like one whole lesson to finish group two, but apparently we finished quite fast. So we have time to move on to a new chapter. Alright, guys, all this homework, you can try to do it, yeah. Okay, so these are all the questions, right, for you guys to practice for your group two. Okay, group two alone has 91 pages. It's crazy, right? Even the conversion, right, it's lagging, bro. The entire file is too big already, guys. Give me a quick one. Okay, just chill for a bit. Alright, guys. Meanwhile, right. Okay, while waiting, meanwhile, how about we do this, guys? Can anyone give me the answer? Go. In 1 minute, I'll show you the answer. Go, go, go. We start the conversion is done. OMG. I'm gonna kill Ivana. Guys, I'm dropping a bomb to the group. A bomb is coming up. Don't be surprised, huh? Alright, I'm sending it now. Yeah, the bomb. It's already in the group. Let's go, guys. Open up the bomb. I love it. I love it. Guys, I'll give you guys 2 minutes to prep yourself, yeah? As you can see, I'm not exaggerating. 140 pages. You guys been with me for more than a year already. I hope at this moment, right, you guys don't go and buy any of you guys. Don't waste paper, don't waste money on your topical past paper, yeah. If you're still buying topical past paper, God bless you. Okay, I already mentioned since day one, right? Do not buy any topical past paper, yeah. If you have too much money to spare, rain it on me, yeah. So I already compiled everything for you guys. Super, super completed version. Yes. 140 pages. Let's go. Do until you die. I have someone finish everything. In 2 minutes, I will start at 8:15. I will start at 8:15. I will start the class, guys. Let's go. Please print it out. He really hacked your notes when sleeping up. Of course, hack my note to sleep. Confirm is 150 pages. Just imagine you print it out. It's that thick. It's like the book already. Yeah. I'm sending you guys bomb. I think this is the longest chapter. No, 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 no. I have another chapter, yeah. Analytic. It's about touching 200 pages. Yeah. Yeah. So good luck. Anyone printing it out, good luck. Let me check now. If I'm not mistaken, it's 160 pages. Really? If you print, wow, you challenge me. Okay. Hey, no way, 100 pages only. This is sticker. Cannot. I need to add more question in it. Do until you guys die. The goal is to send you guys a lot of questions. Alright, guys, 1 more minute. I will start. Okay, let's go, guys. Alright, guys, you see, right? Where you can find your transition element, right? So transition element, right, is between your S block and D block. Okay, it's in between your S block and your P block, yeah. Done. Okay, but not all the P block, right? Sorry, but not all the D block element is known as transition element. Okay, so guys, to understand what is a transition element, right, you have to know their definition first. Okay, the definition of transition element, right, you have a few criterion. So the first criterion is it must be a D block element. Must be a D block element first, yeah. So a D block element is a must. Okay, that forms more than one or more stable ion with an incomplete d orbital. That's it. Alright, guys, this is the definition. The first criterion must be a D block element. Second criterion forms one or more stable ion with incomplete d orbital. Alright, guys, write this down, please. Okay. Okay, guys. Right now, let's look at some exception. You see, right, guys, not everything on the D block, okay, it's a transition element. Example, we have scandium and zinc. So, guys, scandium and zinc, right, are not a transition element here. Okay, so there's a reasoning behind. Okay, guys, if you look at scandium, right, why scandium is not a transition element, right? Reason being scandium has no electrons in the 3D subshell. Guys, let's look at scandium. What is the electron arrangement for scandium? It's gonna be argon, 4s2, 3d1, right? Okay, guys, when it forms a scandium 3 plus, so you eliminate 2 electrons here and 1 electrons here, right? You see that there's no electrons in the d orbital. Am I right? So which make it, okay, doesn't fulfill this criterion, incomplete d orbital. You must have an incomplete d orbital. Okay, highlight this part. No electrons in its 3D. Hey, boy. Okay, why? Reason is 3D04S0, right? So scandium 3 plus has no d electrons. Okay, so it has no d electrons, doesn't meet the criterion. Alright, guys, the next one, I want you guys to try out zinc and Zn2 plus. Go write down the electronic configuration. Let's go. Oh. Yeah, my bad. Sorry, SC, right? Hey, Cindy, Mr. Austin texted me saying you have a friend, right? Right, is it? Did she? You can ask he or she text me directly. Hey guys, now let's look at Zn. For Zn, it's here, right? So electron arrangement. Three D10 4s2. So when it forms an ion Zn2 plus, it loses 2 electrons here, turn into a 3d10, 4s0. Correct. So I know that Zn2 plus has a complete 3D subshell. Am I right? So again, the criterion is incomplete, must have incomplete. Okay. So because your Zn2 plus is 3d10, 4s0. So 3d10 have a full d electrons, and it doesn't meet the requirement also. Understand? So guys, please write it down. Yeah. Done? Alright guys, right now let's go. Okay, let's look at the electronic configuration. Okay, the only exception, right, that we have is chromium and copper. Yeah. Why? We have 4s1 and 4s1. Okay, just chromium and copper is special. Okay, that's it. All right, guys. Now you see, right, in atoms of the transition element, right, the 4s subshell is normally filled, and the rest of the electrons occupied 3d, right? So remember, guys, when you fill, right, you fill 4s before 3d. Okay, guys, you have two exceptions. Chromium and copper are the only exception here. Remember, chromium, copper are the only exception. That's it. Okay, guys, if you look at chromium, right? Okay, so why chromium? Okay, why chromium needs to achieve 3d54s1, right? Reason being, if you look at chromium, maybe I put it here. Okay, for chromium, right? If you look at its 3D, 1, 2, 3, 4, 5, 3D, and 4s. Okay, so let's say if it's a 4s2, right, and 3d4, you have empty d orbital, you don't want it. So usually, right, okay, chromium will fill all its empty orbital with 1 electrons. Okay, so any other electrons come in, right, okay, they can accept it easily. Okay, so chromium, the remaining 5 electrons are arranged in a 3D subshell, so each orbital is occupied by 1 electrons. Alright guys, what about copper? So guys, for copper, right, if you look at Cu, it's the same thing. This 3D, and you have a 4s here. Okay, so for copper, right, okay, it's completely filled D, and 1s, the 4s has 1 electrons only. Okay, so for copper, 3D subshell, it's occupied by both electrons, by 2 electrons. That's it. Okay, guys, please write it down. Yeah. Alright, guys, when you are losing electrons, right, I want you guys to add another study tips here. electrons are lost in 4s first, then 3D. Okay, when you are filling electrons, right, we fill 4s before 3D. When you lose electron, also 4s before 3D. Write it down and I'll move on. OGG. Unfortunately, guys, okay, we'll stop here because the next part, right, is very lengthy. I need about 15 to 20 minutes to go through it. Okay, so that will be all for the class today, and I will see you guys on Friday. Yeah. Bye-bye. See ya. Please like and subscribe. Please like and subscribe.